Good evening and happy New Year to all of you officially. And right, okay, let's start the lesson. So we have discussed about our processor last day and also about some other components related to the computer, especially the peripheral devices and hardware components. So if you can remember, so let me remind the things since we have learned that in 2022, sometimes you might have forgotten this by 2023. So let's revise that and then continue to the lesson. Okay, as we learned in 2022, the computer is a system. It has a lot of components. A system is not just a single thing. It is a set of components work together to perform a specific task. It is a set of components which work together to perform specific tasks. The computer system has three components. So one is hardware. The second one is software. And the third one is liveware. So can you remember the difference between hardware, software, and liveware? Can anyone tell the difference? Yes? Hardware, software, and liveware. What's the difference? Hardware are, yes, physical or tangible components. In case if you cannot remember, hardware are physical or tangible components. අතින් අල්ලලා බලන්න පුළුවන් දෘඩ කොටස්. Physical, භෞතික කොටස්. Physical or tangible components of the computer system is called hardware. Software. The software කියන්නේ මොනවද? What is software? Yes. Leisha. So what's software? Hardware are tangible components. Software are, yes. Senodi, what is software? Senodi?
Software are the systems that can't be touched.
It cannot be touched. It is basically instructions. You can call it is a set of instructions, right? It is a set of instructions to the computer which cannot be touched. It is a software. It is inside the computer, but you can't touch that. It is there as a set of instructions. Then liveware. Liveware.
Human working.
Yes, people work with this hardware and software. We call them liveware, right? The people, human, are working with this hardware, software. We call them liveware, right? Okay. So then we have learned about the hardware subsystem, right? We have further divided hardware. So let me write there. Hardware are physical component, right? Physical components. ඔයාලට මතක නැහැ කියලා හිතලා තමයි මම මේ ලියන්නේ. හරිද? Physical components. භෞතික කොටස් තමයි hardware කියන්නේ. Software කියන්නේ අල්ලන්න බැරි instructions, intangible instructions. හරිද? එතකොට liveware කියන්නේ people. හරිද? මේක use කරන මිනිස්සු. Hardware, software use කරන මිනිස්සු තමයි liveware කියලා කියන්නේ. Okay, those are the three things. Then we have further divided hardware into 6 subsystems. Can you remember what are they? Yes? What are the devices that you can see? Physical level bedanne kohomada api? So one is input devices. Can you tell me the other things?
Output devices, storage devices,
Storage devices.
Correct. Processing devices.
storage devices,
Yes, storage devices which store for a long time.
main memory,
Memory devices, the temporary storage, which is main memory or the memory devices or primary memory. It is a temporary one, but storage is permanent. The last one is
communication
devices. Exactly. Very good. Communication devices. So those are the devices that we can see in the hardware subsystem. Input devices take inputs. Give me examples. Mouse,
Keyboard,
scanner,
microphone, web
keyboard,
camera,
microphone,
scanner.
web camera, scanner.
Type
Correct.
pen,
Very good.
scanner.
Yes, very good. Output devices.
printer, speaker, multimedia
Printer,
projector,
monitor,
Printer,
Headphones.
speaker, projector, multimedia, projector, monitor. Correct. Exactly. Very good. Processing devices. Processing devices. There are two processing devices. One is CPU. The other one is called GPU. CPU is a central processing unit. The other one is graphic processing unit. There are two, right? VGA card වල තියෙනවා GPU කියලා එකක්. ඒතර CPU හරි ඒක normally තියෙන එක normal processor එක GPU කියලා එකකුත් තියෙනවා. Storage devices examples.
so internal storage,
Hard disk drive,
pen drive,
SSD, pen drive, CD, DVD, තියෙනවනේ නේද? කොච්චර තියෙනවද? CD, DVD, pen drives, all these are storage. Primary memory examples. Random access memory. It's a primary memory, right? Communication devices examples.
NIC, modem, router,
Router, modem, NIC. These are. Okay, then the input devices, keyboard, mouse, output devices, screen, printer. Okay, likewise, we have learned about all these 6 categories of devices. That is in the previous year, year 2022. Now we are in 2023, a new year. So we are going to learn about the new concepts. Okay, first of all, you can write down the heading, components inside the processor. And so then please write down this and draw this diagram, this part, right? No need to write the Sinhala medium note. Only write the English medium part and draw this diagram quickly in your book. Please write down in your book. Right. Here you can see few components and we are going to learn about them individually now. Central processing unit, I said this already, it's like brain of us. The CPU is similar to brain of a human body. Why? You know how important the brain to us. Without brain, we cannot tell that we are living. So in accidents and all, I think you have heard of sometimes when the brain is damaged severely and it is unrecoverable, we call the person is dead. Even though the other organs are working, maybe heart is working, hands, legs, nerve system is working sometimes, maybe the kidneys, eyes and other organs working, but still we call the person is dead. The reason is the brain is not functioning. So that is the situation. Similar to that, in our example, in this computer world, the brain of the computer is CPU. CPU is also playing such a vital role in computer. So let's assume the CPU is not working, then we can consider the computer as a dead one. The reason is it's not functioning. Whatever the process, even though it is an input, output, storage, communication, memorizing, whatever it is, you name it, any function should access the CPU. That you can witness, right? So let me show that. Who can share your screen? So I hope that if you're using Windows, you can share the screen. I can show you this. Okay, Lisha. So can you just minimize this and just go to the processor? So let's go to the task manager, and task manager can show you the running processes. You can right click over there or here in the Windows button and select task manager. Okay. When you select the task manager, you will get the task manager dialog box. There, please go to the performances. And you can see this, how CPU is functioning. CPU is functioning there. You can see the CPU diagram. Okay, let's do small thing. Very small thing. I want you to open Microsoft Word. Microsoft Word if you have. See the CPU diagram. When she is trying to open Microsoft Word, the CPU diagram indicates the processing moves up. Here, it moves up. The reason is Leisha has opened Microsoft Word. Let's close Microsoft Word now. Take it and close it. Still, when you're closing, you can see this diagram is showing the process. Okay, let's do small thing. So this is, please restore down this. Restore down to the normal size. Then click on this and move this both sides fastly. Click on the here, click on this, and then move it. Move the window. Window එක දෙපැත්තට move කරන්න බලන්න. Just click on the window and move it both sides. Hello. Am I audible? All right, okay. Move it quickly, Pute. Move it quickly to both sides. Putting allala, me hading allala, දෙපැත්තට move කරන්න. පුළුවන්ද? Can you do that? Yes, you can see when you're moving, can you see the process diagram? It will move up. Processing diagram, it will go up. That happens. The reason is with each and every input, output, whatever task that you are done with that you're doing with the computer, it is indicated and it is affected to your processor. That is the reason. Okay. So let's write down about the components of the processor. The first one is ALU. Meaning is arithmetic and logical unit. Sometimes called arithmetic logical unit or arithmetic and logical unit that will perform mathematical functions like addition, subtraction, division, multiplication, එකතු කිරීම, අඩු කිරීම වගේ දේවල්. And not only that, it will do the logical operations like comparisons, whether the number is greater than or less than, whether it is equal, not equal, unequality check, equality check, all these things, grouping, sorting, merging, right? Filtering, all these are called, අපි මේක group කරනවා, sort කරනවා කියනවා, A to Z. ඊට පස්සේ bold කරනවා, italic කරනවා, ඒ ඔක්කොම logical functions. ඒ කියන්නේ තියෙන தත්ත්වය වෙනස් කරනවානේ. Bold, italic. So these are logical functions, changing the font sizes, grouping, checking equal to not equal to increasing, decreasing. So all these functions are done by ALU, arithmetic and logical unit. So please write down this part quickly. The functions of ALU, please write down quickly. And also write down about CU, right? Both, please write down about ALU, CU, both. I will explain CU after you write, right? You got to pass them on explain karanang. Then ALU, CU. Right. Then, so I couldn't explain about the control unit. No, control unit is like traffic manager, or it's like traffic police, right? Okay, it is like a traffic police or traffic manager. Actually, what it does, right? Traffic police or traffic manager will control the traffic or manage the traffic, but it is not going to actually drive the traffic. Traffic manager in the middle of a junction is not going to drive any vehicle, no. But instead of driving, he's commanding the vehicles to go here and there. So that is the nature. right? Similar to that, actually our CU inside the processor is not doing anything but signaling other components to do something. Okay, so that is that means when there's an input, it will signal, right? It will signal the particular input device to take that. When output, it will signal a particular output device to output. When it is a memory, it will signal the memory to take that. Likewise, it will signal. It's like a traffic police signal. And also, there's another thing. Everything in the computer is happening through its machine language. It is advised or it is controlled by the machine language. Hope you can remember this symbol. This has 1 and 0. This 1 indicate on and 0 indicate off. 0 indicates off. Actually, this is the simplest way that you can give a signal. This is the simplest signal format. But there are some other signals. That means, okay, let's say there's a picture. Okay, there's a letter. Letter A has this signal. And letter B has this signal. Letter C is this. Likewise, each and every letter has a binary 1-0 signal format. Everything need to be given using this on-off signals. On-off signals, 1-0 signal. So the language will be very complex, right? Because we have a lot of words to tell things. Here you can see this note is given using a lot of words. So each of these words has a meaning. But here, all the words, all these things are constructed using 1 and 0, 2 symbols. How complex the logic is. It's simple. Yes, it is simple, but the logic, simple language, complex logic. මොකද ඔක්කොම කියන්න ඕනේ එකෙන් බින්දුවෙන්. පින්තූරයක් ගැන කියන්නත් ඕනේ එකෙන් බින්දුවෙන්. You have to tell about a picture using 1-0. You have to tell about a video using 1-0. When you want to tell about audio, you have to tell it using 1-0. Letters using 1-0. Documents using 1-0. How complex that in representation, right? But anyway, this complex representation is called machine language. It has only 2 types of signals, on-off signals, 1-0 signals. But the CU can understand, decode, or CU can understand this machine language. That is the amazing thing in CU. Control unit understands machine language. These codes, these 1-0 codes can be easily understood by CU. So CU has 2 tasks. What are those 2 tasks? Number 1 is signaling all sending control signals. Number 2, understanding machine language. You can highlight these 2 points, right? In case if you cannot remember them, better you highlight it. Basically, sending control signals is one task. You can wall it. The other one is understanding the low-level instructions or the machine language, right? Low-level instructions means machine language. In bracket, you can write machine language. Okay, that's it about CU. Okay, let's move to the next point. Okay, let's move to the next point. Next is the memory unit, MU, memory unit. Please write down about memory unit now. Okay, what it says. Okay, here you can see hard disk, then the random access memory, then the cache, and here. So what is this? Actually, the memory unit in the computer is responsible for holding the values, holding the instructions, data until we process. Okay, think that you are eating something. When you are eating, what is your primary processing unit? Yes, at the time you are eating, what is your primary processing unit?
Tongue.
Yeah, it can be tongue, it can be teeth, it can be anyway. Let's take as mouth, whole unit. So, we need some storage capacity in mouth. Earlier days, dinosaurs, they had big mouth, so they could eat a big meal. They could take a big meal because their mouth is so big. But think about a cockroach or think about a small insect. It's having very small mouth, so relatively small amount of food can be taken by them. So as human beings, we also have a mouth, but our mouth is considerably in the medium size. We can consume amount of food based on that. Actually, amount of food until it processed, we store that in mouth. Similar to that, remember this cache memory. Cache memory is like mouth in your processor. Processor is the processing area, processing unit. Until it processes, it holds the instructions and data in this cache memory until it processes. And even after immediate processing also, it will be stored in the cache memory. Cache memory is where the data and instructions are stored when processing, at the processing time. Okay, so then let's clear out the ladder now. So basically, whatever the instruction data now, even this document is in hard disk now, a kind of hard disk. That is a secondary storage. This document, week 1, lesson 1 is also there in the hard disk, right? That is storage. From that, now we have taken that to the memory. Now this is in actually the snapshot for the current movement. The present page that we are reading is there in our random access memory. So this is like a book in your book track. This is the current page that you are. This is set of books in your book track. The current book is the book that you have taken from the book track. That book is that current book. Currently accessing things are there in the random access memory. Okay, the things stored in the book track store කරලා තියෙනවනේ, ගබඩා කරලා තියෙනවනේ, ඒ වෙලාවේ ගන්නේව නෙමෙයි. හැබැයි currently accessing things. From the book track we take one book. Currently accessing things are there in the random access memory. Currently reading page is there in the cache memory. That is the, okay, think about bread. This is bread in the bakery. We bring one to our house because we are going to access it now. That is in your lunch table now. From that you take slices. These slices are there in your cache memory, then gradually it will go to your mouth. Okay, that is the ladder, right? Understand the flow of data. It is basically stored in a storage medium for permanently, for a long time. From that, for currently accessing, we are taking into random access memory. From that, for the currently processing, we are taking into the cache memory. ඔය ස්ටේජ් තුන මතක තියාගන්න. ස්ටෝර් කරලා තියෙන්නේ hard එකක, storage එකක, දැන් access කරද්දි RAM එකේ, දැන් process කරද්දි cache එකේ. සහ registers වල. Register is the smallest unit. It is like your teeth. That වගේ registers. These are small memory cells which you can use for processing. Right? That is your registers. So understand this clearly. Okay, now you can finish writing quickly. Or if not, you can take a snapshot of this and write down later. Whatever your preference, you have to do anyway. Finish this within today, right? Don't delay it. Okay. Then, at the end of session, what I would like to remember is we need to remember, right? So have you finished writing or still writing? Hello? Finish. Okay, good. Right. Then, according to your book, we have to learn about few more things. That is the history of this computer system and its processor. We need to learn about the history. So let's refer to the book now. So according to your textbook, reading book, you can go and read the text. And there are 4 generations listed in according to the computer processor. There are 4 generations. So what are these 4 generations? The first generation has used vacuum tubes. In the first generation computer, it has used vacuum tubes. What are these vacuum tubes? Okay, what are these vacuum tubes? Vacuum tubes are something like this. This is the shape. In all radios, there's wireless kind of radios. There was something called wireless, right? In that radio, you can see this vacuum tube. That vacuum tubes are really large. It's like 1 feet, 2 feet height. Sometimes, right? This is bigger. Sometimes it is few inches. Sometimes it is few feet, right? So anyway, so this is inside the first generation computer. Think about the size. This is inside the first generation computer. Actually, we can go inside particular computer. Unlike now, we cannot go inside our laptop now. We cannot go inside and repair our desktop. But we can go inside and repair the first generation, very old computers. It is like a large building. If you want to own such computer, it's not possible. Why? How can you bring a building to home? It's not possible. How to transport that building to your home? No space. Not practical, not possible. The computer එකක් building එකක් වගේ. ඉතින් මේ building එකක් වගේ ලොකු computer එකක් කොහොමද ගෙදර ගෙනියන්නේ නේ? It's not possible. It's not practical. Right? It's not practical. It's not possible to bring such large computer to home. So that is a large computer. Few people can work inside this computer. This is inside the computer room. Right? It's only one computer, right? This is only one computer, but you can see how large that computer is, like a large building. Computer is like a large building. 8-vac, UNIVAC. Vac කියලනේ vacuum tube පාවිච්චි කරපු ඒවට. 8-vac, UNIVAC කියලා එහෙම තියෙනවා වගේ නම. Right, this 8-vac, UNIVAC. So these are, you can see few people are working inside the computer. So computer is a very large building. So because the vacuum tube, these switches or the vacuum tubes are very large in size. Therefore, the scale of the computer is very large. And that is how the processor is built in the first generation. So we will gradually learn about the other generations also. We will learn about the other computers in the second generation, third generation, and the modern computers. That I'll be discussing in next day, right? And we can wind up the lesson and we can move to the workbook after that. Okay, then I'll stop from here. Good night and see you all next week.
Thank you, sir. Thank you, sir.
Good night, sir.
Yeah.